Hi everyone, welcome to this video. In this video, we are going to know about few definitions which are involved in electrical engineering. So with the knowledge of these definitions, you can understand the concept of electrical engineering in a much better way. So let us go with what are the definitions which we are going to study. So these are the few definitions which we are going to learn in this video. The difference between network and circuit, linear and non-linear elements, active and passive elements, what are unilateral and bilateral elements. So what is a lumped element, what is a distributed element, and what are time variant and time invariant networks. So let us go to a network actually. Network is a combination of active and passive elements of circuit elements. So you can see the circuit elements can be voltage sources, current sources, resistors, inductors, capacitors. Here is a figure where R, L, C are connected here. But what is a circuit? A circuit is a network which consists of at least one closed path. It should have one closed path and it is called as an electrical circuit. So it can be said that, so you can see that all networks can become a circuit, but all circuits cannot become a network because the circuit requires the closed path. Every circuit is a network, but all networks are circuit. Because if you look at the example, it will be more clear for you. Resistor, inductor, capacitor, and voltage sources are connected in series and it forms a closed loop here. But if you look at the network circuit, it doesn't form a closed loop here. So this is a circuit and this is a network. This is a circuit as well as a network, but this is network alone because it is not a closed path. We'll go with the next definition, which are linear elements and non-linear elements. What does linear element in electrical engineering mean? If voltage changes, then the corresponding response changes accordingly, then it is called as linear elements. What is this accordingly? If they change according to Ohm's law, if the voltage increases, then the current also increases in the corresponding way. Then it is called as linear relationships. So the examples for linear elements are resistors, inductors, capacitors. They are called as linear elements because here V is equal to R into I. If you look at the inductor, we talk in terms of inductive reactance. V is equal to XL into I. And if we talk about capacitor, V is equal to XC into I. So they are linear elements. So if you can look at the graph, it is a straight line passing through the origin. It has the characteristics of a straight line passing through the origin. It looks like Y is equal to MX relationship. Non-linear elements. So the elements which does not have the response of Ohm's law, Y is equal to mx kind of equations are called as non-linear elements. So you can look at this figure, non-linear elements, or they have their own diagram actually. I represented by a diagram here. So they don't obey Ohm's law. Or if I increase the voltage, the current will not increase accordingly. So these are, it does not obey Ohm's law. What are the examples? Voltage dependent resistors, commonly called as VDR, and later voltage dependent capacitor, very commonly called as varactor. Next is temperature dependent resistor, which is called as thermistors, and later LDRs, light dependent resistors. These are the few examples for non-linear elements. We'll go with the next definition, active elements and passive elements. So here the definition goes like this: an element which is a source of electrical signals, so which produces electrical signals or which is capable of increasing the level of the electrical signal is termed as active elements. Either it produces signal or which is capable of increasing that electrical signal are called as active elements. The first example goes is what all we know are batteries. BJTs, because we can use them as amplifiers. FETs also, they are used as voltage amplifiers. Op amps, we increase the signals by using operational amplifiers. Basic generators, solar cells, these all come under active elements. What are passive elements? The elements which consume electrical energy are termed as passive elements, like resistor, inductor, capacitor. As like we previously discussed, VDR, LDR, thermistors, they are all called as passive elements. We'll move with the next definition, which are unilateral element and bilateral element. As the name indicates, if the passage of the current is only in one particular direction, or it is able to pass the current in only one particular direction, it is called as unilateral element. The best example is the semiconductor diode. You can see it has anode and cathode. The current passes from anode to cathode only, and it is impossible to make the current to pass from cathode to anode. So that's why it is uni. Uni means only one. It has only one way direction of current flow. Bilateral element, if the current can pass, as the name says, if the current can pass through both the directions, then it is called as bilateral element. As like resistor, we can move the current to move from left to right, right to left, top to bottom, bottom to top, or in a closed loop, it can move in clockwise and anti-clockwise direction. So that kind of elements are called as bilateral elements. With this, we'll move to the next definition called lumped and distributed elements. Lumped element. What is a lumped element? And a lumped element is the element which is separated physically, as like we see resistors in the lab or capacitors, inductance we see in the lab. They are all called as lumped element. So, and you can see this is just a circuit given here. Resistor, inductor, capacitor connected in series to a voltage source. We'll go to distributed element. Distributed means they are distributed all over. The resistance, inductor, capacitor, all the elements are distributed and which are not separated. You can't separate them individually if you want to analyze them. They are called as distributed elements. So the example for distributed elements is the transmission line. The power transmission lines, we can call them, where we have resistance, inductance, and capacitance distributed all over the transmission line, from the transmission generation to transmission utilization of the power. From the power generation to utilization of power, you have resistance, shunt capacitance, and series inductance all over the transmission lines. They are called as distributed elements. So with this, we'll go with the next example called time invariant network and time variant network. As the name indicates, so it does not change with respect to time. The input and output does not change with respect to time. If at all there is a time shift in the input, then there is a time shift in the output also occurs. So these are the networks basically. In this network, so the time it doesn't matter actually. If at all there is a shift in the time in the input, then the output also shift in the time occurs. So what is time variant network? It is a network in which the input output changes according to the time. It is a variant changing with respect to the time. They are called as time variant networks. So with this, I thank everyone with this video. Thank you all. So these are the these are the 6 definitions which are important in basic electrical engineering concepts, along with the examples to understand the concepts of electrical engineering are the forthcoming concepts which you are going to study in electrical engineering. So with that, I'll thank you everyone for watching this video. Thank you.